Now, this is the third likely question for WAEC 2026 um, chemistry practical examination. Okay, if you have not watched the first and the second one, I will strongly advise you also watch those ones. Okay, so over the years we have been creating questions like this, and it has always 80 to 90% of time this question, your exam question will not be more than this. So this is another episode on that. Okay, so do well to watch um, the part one and part two. Now, what do we have here? Okay, the first two questions did not talk about purity. Okay, but this particular case, we are going to be looking at what if you want to calculate percentage purity of uh, one of the reagents that is involved in the titration. In this case, purity of sodium hydroxide. How will the question be tested? So now, as I said, we are not going to be performing the titration experiment. We are assuming the titration experiment has been performed and our table has been prepared, because this table and titer value is going to carry about 10 marks. Okay, so this is what the table really matters in your, it carries over 50% of your marks. Okay, this table over 50% of the marks in question number one. Okay, titration. Question number one typically carries from 21 to 23 marks. Okay, so you should ensure that you prepare this table um, very, very well, correctly. Decimal places, units correctly stated, and your titer value also correctly calculated. Ensuring that the values you pick for calculating your titer value is not too far from plus or minus 0.20. Okay, and your titer value also should try as much as possible to perform the experiment accurately. Okay, so your titer value shouldn't also be too far from that of your instructor's own. So let's say your instructor performed the experiment, yours should not be more than 0.15 cm3 plus or minus, give or take 0.15 for you to get the maximum mark. Though if yours is about plus or minus 0.2, you still get mark, but you will not get all the marks if your theta value is lower or higher than 0.15. So please take note of that. So we are focusing more on the calculations. Okay, the table presentation and the calculations, assuming you have done the experiment. Okay, now let's read the question. So A is a solution of H2SO4 containing 0.103 mole per dm3, and B is a solution prepared by dissolving 4.5 gram of impure sodium hydroxide in 1 dm3 of distilled water. Now observe that we were told that the sodium hydroxide is impure. Okay, for the fact that it is impure, okay, we cannot determine the concentration of B directly from this impure substance, um, because of the fact that it is impure, and we have impure is always equal to pure plus impurity, meaning that the sample contains the sodium hydroxide and some impurity. Okay, and when we say impurity, it does not necessarily mean deaths. It could mean that during the course of preparation, the sample has absorbed some amount of water, hence affecting the actual concentration of the sample. Okay, generally speaking, sodium hydroxide is not used for preparing primary standard solution. It cannot be used to prepare a primary standard solution to standardize another solution, because of the fact that it is deliquescent. So there's another possible question that you can be asked, especially in question number 3, that you can be asked to define primary standard solution. Okay, so a primary standard solution is a solution that uh, that a primary standard solution is a solution that is prepared from a non-deliquescent or from a pure substance. Okay, that's where it is prepared from. However, another question is that you can also be asked around standard solution is, why is sodium hydroxide not used in preparing primary standard solution? Why is sodium hydroxide not used to standardize? It cannot be used to standardize another solution. It's the same reason. Same reason is that sodium hydroxide is deliquescent, okay, or it is deliquescent. When it is exposed to air, it absorbs water and dissolves in the water, or sometimes it also absorbs CO2 gas from the atmosphere. Okay, so that is just an addition to that. So this kind of questions used to come in question number 3. Okay, so take note. Now let's move on. The first thing is concentration of. We are asked to calculate the concentration of A in grams per dm. Okay, you would observe that concentration of BA was given in what? In moles per dm cube. So for us to calculate it in grams per dm cube, okay, we need to use the relationship that connects grams per dm cube, moles per dm cube, and molar mass. Okay, so you recall that concentration in moles per dm cube is always equal to concentration in grams per dm cube divided by molar mass. Okay, so it means for us to get concentration in grams per dm cube, we cross multiply. So therefore, concentration in grams per dm cube is going to be the concentration, which is our Ca in this case, multiplied by the molar mass of the acid. And the acid is explicitly stated to be what? H2SO4. So you need to calculate the molar mass of H2SO4. So sometimes the molar mass can be given, or sometimes you'll be given um, the relative atomic mass of each of the elements present in H2SO4. So the molar mass of H2SO4 is 2 times 1. Hydrogen is 1. Sulfur is 32. And oxygen is 16. So if we compute this, we are going to get 98 grams per mole. Okay. So now, having done that, that means we can get our concentration in grams per dm cube. So our concentration in grams per dm cube is going to be the given concentration of the acid, which is 0.103. So 0.103 multiplied by 98. Okay, and if you punch your calculator, you are going to get okay. Let me quickly punch a calculator to get that. Okay, so we have 0.103 multiplied by 98, which will give you 10.094 grams per dm cube. Okay, if you want to leave your answer in 3 significant figures, it's going to be 10.1 grams per dm cube. Okay, so this is the P Roman figure 1 solution, concentration of A, that is the acid, in grams per dm. Now we are asked to calculate the concentration of the pure sodium hydroxide in B. Now, since we are calculating for the pure, we are going to use the neutralization reaction, because this concentration of this acid is what will neutralize that of the base. Okay, so our Ca is known from the question. Okay, mole per dm cube, and our Va is the titer value, which is 12.20 cm cube. Our Cb, that is for the pure, is unknown, but Vb is the volume of our pipette, which is 25.00 cm cube. And for the fact that it is a neutralization reaction, the reaction ratio between H2SO4 and NaOH can be written. Okay, we can write the state. This one is in aqueous, it's dissolved in water. Then this one is also in aqueous. Then we are going to have a sulfate salt, Na2SO4, it's also aqueous, and we have water, which is obviously a liquid. Okay, so the reaction is not balanced, so we have to balance it. So since we have 2 sodium here, we put 2 here. Then the hydrogen also need to balance it as this. So from here you see that the reaction ratio of acid to base is 1 to 2. Okay, from the stoichiometric equation. Then we write our neutralization reaction formula: CAVA over CBVB must be equals to NA over NB. And our target is to calculate CB. And from here, you see that your CB is going to be CAVANB divided by VBNA. Okay, so you can substitute all the variables you have. Which you have 0.103 multiplied by our VA is 12.20. Okay, you are going to put the one you get during your own experiment. That's going to be your own VA. Okay, then multiply by our NB is NB over NA is 2 over 1. So you can just put that. While VB is 25.00 cm. So if you pick up your calculator, you have 0.103 is multiplying 12.2 multiplied by 2, then dividing by 25. So we are going to get an approximate answer of 0.101 mole per dm cubed. Mole per dm cubed, which is to 3 significant figure. So this is calculated concentration of pure sodium hydroxide. Okay, so now let's proceed. Now the next question we have, let me zoom in a bit. Okay, that's zoomed. So the next question we have is what mass of pure sodium hydroxide in 1 dm cube of solution. In 1 dm cube of solution, that is also per dm cube. Now, so definitely asking you to calculate mass of pure sodium hydroxide in 1 dm cube. This another way of putting it is to say calculate concentration of B in grams per dm cube. That is for the pure one in grams per dm cube. Okay. And now, since we know the concentration in mole per dm cube, and we know that substance is sodium hydroxide, we can calculate the molar mass. Okay. So from here, we are going to say concentration of B in grams per dm cube is what? The concentration of B in moles per dm cube multiplied by the molar mass. Multiplied by the molar mass of sodium hydroxide. So you can quickly calculate the molar mass of sodium hydroxide. So mm of sodium hydroxide is 23 plus 16 plus 1, which is 40 grams per mole. Okay, so upon substitution, you see that your concentration of B in grams per dm cube is going to be 0.101, which is the concentration that was calculated in the previous question, multiplied by 40, which is the molar mass. So 0.101 multiplied by 40, you're going to have 4.04 grams per dm. 4.04 grams per dm cube as the concentration, the mass of pure sodium hydroxide in 1 dm cube. So it's about 4.04 grams in 1 dm cube. Okay. Now we are asked to calculate percentage purity of sodium hydroxide from the sample. Now, of course, the sample we have originally, let's go back and see the sample we have. The sample we have originally contains 4.5 grams in 1 dm cube. That's 4.50 grams per dm cube. Okay, so we extend. We are going to use this is what we are going to use to compute the percentage purity. So percentage purity is mass of pure, or you say concentration of pure over mass of impure mass of impure multiplied by 100 over 1, so that you can convert to percentage. So if you substitute this, mass of pure is given in gram per dm cube. So this is 4.04. It's calculated, while the other one is 4.50. Then we compute this and we multiply by 100, so that we can get the desired percentage purity. So we divide by 4.5. So we have 4.04 divided by 4.5 multiplied by 100. So we are going to get about 89.78%. 4.04 divided by 4.5. Yes, 89.78. Okay, let's check again. We have 4.5. Yeah, we have 4.5. Good. So now the question says calculate percentage impurity. The last question here. Of course, if you know percentage purity, you know percentage impurity. So percentage impurity is simply percentage. It's simply 100 minus 100 minus percentage purity. Okay, so which is 100 minus 89.78. Okay, so we just simply subtract 89.78 from 100, and we're going to get about 10.22% as the percentage impurity. Okay, so this is the second question, the third question. So now we also have a fourth question. Actually, the fourth question involves this question has actually come before in the past question. Okay, many persons might not know that this particular fourth question has come before in the past question. So I'm going to make a separate video where we explain this particular fourth question. You can see it on the screen, where we have the acid was not directly mentioned. Okay, the basicity of the acid was not mentioned, and the anion that's attached, that is present in the acid, is also not mentioned. So I'm going to make a separate video where we'll solve this particular question. So maybe WAEC wants to repeat it again. Question has come before in the past question. Maybe they want to repeat this particular question again. So make sure you have subscribed, so that and you hit the notification bell, so that when I upload other videos, especially this one, you'll be notified. So thank you for watching. See you in the next video.